Hello everyone, welcome to my channel Being Software Engineer. My name is Akash. So today in this video we are going to learn what are the different atomic operations in concurrent hash map and how they are useful and why we should use them. So concurrent hash map, as you might be knowing, that it works on segment level locks, so not complete map is logged, but only segment of the map is logged. So let's check an example. So suppose we have 3 entries onto the same bucket. This situation occurs when we have similar hash code for multiple different objects. So suppose we have 3 entries and and we have update operation on this third key value pair. Then only this particular entry will be, this particular segment will be logged, and other segments will be free for all update and read operations. So this is how it is efficient. But in case of hash map, the complete it's not thread safe at all. So we make it concurrent modification exception when we try to perform read and update operation on the same map. In case of hash table, the complete hash table is logged by the single thread, so which is not efficient at all. But in case of concurrent hash map, it's very efficient. So like we have get, containSKey, all of these operations are thread safe. So let's check how these atomic operations, what are these atomic operations and why we should use them. So there are 4 atomic operations in concurrent hash map: putIfAbsent, computeIfAbsent, then we have compute, and we have merge. So why we should use them? Let's take an example and let's try to understand. So suppose we have this example where we have, first of all, I have created concurrent hash map with by adding 2 fruits, apple with 2 quantity and banana with 3 quantities. So I have initialized this fruits concurrent hash map with these 2 fruits. So suppose we are trying to check if this orange contains into this fruits. So it doesn't contain, so it will try to we will try to put it with value 5. So what happens with this containSKey? So this containSKey is not it's a thread safe, so multiple threads can enter into this block and update at the same time. So let's say there are two threads, thread A and thread B. So both will enter, both will check, oh, this orange does not exist, so both will update orange as 5. So what should be the ideal operation? The ideal operation should be like thread A should check and thread B should not. Thread A should check and thread A only should update this orange as 5, and then when thread B will come, then thread B will see that, oh, it's already exists, so it will not update it again, because we see that it's only updating it with 5. But what if the operation is very heavy, it's very expensive, like it's calling database and it's trying to update the values. So in that case, updating twice may be very performance inefficient. So that's when we should use putIfAbsent. So putIfAbsent is atomic thread safe operation of concurrent hash map. Here only one thread, what atomic operation is? So atomic operation is a single unit of undivisible operation. It means that only one thread will complete the complete operation, and other thread will not be able to enter until that time. So only in this case it will thread A only will execute everything, and thread B won't be able to enter until this operation is complete. So this is how we can avoid multiple threads operating the same entry. Let's talk about computeIfAbsent. So computeIfAbsent is it's really powerful in case of computing. So let's say we are trying to check the mango count, if there is a mango into that fruits. So there is no mango, but we'll check if the mango count is null. If the mango does not exist, then we'll check, we'll initialize the mango with 1, and we'll put that mango in it. Suppose this mango is not a mango, we are trying to call db here, db, to get the mango count, and then both the threads enter into this thread A and thread B check mango count, it doesn't, it's found as null, so it will check, it will so thread A will call db and it will get the value of mango, let's say 5, and then it will update the mango count as 5, and again thread B will which already got count as null, it will check, it will call db and it will get 5 and it will update the fruits to 5. So it is again, you know, it will update the same entry with the same value again, so which is not ideal at all, which we should avoid. So in this case we should use computeIfAbsent. So computeIfAbsent will you know, it's an atomic operation, so it will just check the mango. If the mango exists, it will update the mango value to, you know, the one which we want. So yeah, so compute, in case of compute, when we should use compute, suppose we want apple count. So we got the apple count here and we are putting apple count, we got the apple count which is 2, and then we updating the apple count here, which is put by apple count plus 1. So in this case both the threads will update the apple count to 3, which is not the ideal case. It should, the ideal case should be that apple count should be 4, like next thread should read it has already 3 and then it should update to 4. But in this, as it is atomic, I mean it is not atomic, so both the threads will update it to 2. It will read, both of them will read the apple count as 2 and it update it to 3. But in case of compute, what will happen is it will check the apple, if the apple contains, yes, apple contains, what is the apple count? So apple count is 2, so it will automatically update, it will update the value to 3. It will not re-update the value. So only one thread can do the complete operation, which is that is why it's called as atomic operation. We can also do like this, like if value is null, then if the value is null, then return 1, else return value plus 1. We can also perform operations, such operation in compute. So in case of merge, so merge we use when we want to perform some arithmetic operations on the old value and the new value. So suppose we are trying to put, you know, fruits, I mean we will first we'll put fruits, I mean we'll check if it is there, if the banana is there, or else give the value as 0. So if the banana is there, then add the value with 2. So it will what it will do is both the threads can perform this operation, so it will get the same value and it will update it with 2. But in case of merge, only one thread can execute this operation, and what it will do is it will just get banana value and it will update with the new with add it with 2, and it will get the final output as banana is 3, so we'll get final output as 5. So because this is the sum operation. So this is how we should use these 4 methods: merge, compute, computeIfAbsent, putIfAbsent, and these are very important methods if we want to perform any atomic operations. So yeah, that's all for now. Thank you very much for watching this video. If you like this video, please like this video and please subscribe my channel to get updates on new videos. Thank you very much. Bye.